All right, we're going to go ahead and get started here. My name is Dave Farmer. I'm the Center for Excellence Director here at Zoeller Company. We appreciate you joining us for our control panels webinar today. Before we get started, I just want to cover a few details. Please note the email address that's on the title screen there in front of you, that webinars@zoeller.com. If you have any questions after we wrap up today, please send any questions to webinars@zoeller.com and we will get back to you. Now that those details are covered, I'll just go ahead and start off and I'll tell you a little bit about myself. Again, my name is Dave Farmer. I've been with Zoeller Company for a little over 16 years now. Prior to my time with Zoeller, I did electrical work for about 10 years. During my time with Zoeller here, I've done a number of different things, one of which was operate a wastewater service company for Zoeller. I did that for about 6 years. We did a lot of different things at that company. One of the big things that I did was service a lot of different types of control panels. I did a lot of startups out there in the field, so I got to see a lot of product out there. Also, during my time here at Zoeller, I've also worked under the Clarus Environmental wing of Zoeller Company, working with our on-site septic system products. I was also in Zoeller product support for several years, as well as inside sales and commercial quotes. So anyway, in 2015, Zoeller Company opened up its Center for Excellence Training Center here on our headquarter campus in Louisville. I began assisting with those trainings in 2015. In January of 2020, I became the director for the Center for Excellence, where I continue to work with customers as well as internal staff, and I try to pass on my years of knowledge and hands-on experience. So now that you know a little bit about me and my background, let's go ahead and get started. Today we're going to discuss control panels. I plan on focusing more on components that you might find in just about any control panel out there, discussing what they do, how they work, their functionality. I plan on trying to give you some troubleshooting tips along the way. And then at the end, I will conclude with some best practices that I think will help ensure you have a long-lasting system. So first thing we need to talk about when it comes to control panels is safety. Remember, we're dealing with electricity and water in all of our applications. Both can be hazardous, but put them together and, well, you have a situation where it's just extra important that you use your head and stay smart when working with our equipment. Our number one goal is to make sure you return home safely at the end of each day. One of the first things that I want to point out just from my time in the field is take the time to find the circuit breaker or circuit breakers that feed power to your control panel. Something I used to do out in the field is take a Sharpie marker and write down those breaker numbers and maybe what panel they're in or its location. Just write that inside of your panel door. You never know when you're going to need it. And when you need it, it's a lifesaver to have it right there. So I think that is a great first thing to mention. Next, I want to mention, use a meter. Use an electrical meter to verify that power is really off before you touch anything inside of a control panel. Use your head. Think before you act. This is especially important, again, with working with electrical devices and pumps. You got floats down in the water, you got pumps in the water. This is really important. Make sure you use your head and you think before you act. Kind of going along with that, don't get distracted. You're going to. It's going to happen. But if you do get sidetracked, or when you do get sidetracked, be sure to just take a moment and just kind of hit reset there and get your head back in the game and where you were at before you just dive back into working on a control panel. You just can't be safe enough. Again, check the voltage. This is not only to check it to make sure that it's off, like I previously mentioned, but I'm saying at this time to verify the voltage. Verify the voltage is correct for both your panel and your pumps. Sometimes you have different voltages for the panel and the pumps. If you have the wrong voltage going to especially your control panel, you can fry or burn up components inside of a control panel in just the blink of an eye. It can be a very expensive learning lesson and, of course, not to mention dangerous. Lastly, take it from me, there's nothing more scary than working in any kind of electrical panel and have your cell phone on vibrate in your pocket. Trust me, it will scare you to death. When you're working on an electrical panel, make sure to switch your phone to an audible mode or take it out of your pocket completely. It's just not something you need to be distracted or scared by. Next, I want to talk about electrical meters. Again, if you're working on a control panel, you're going to need an electrical meter. This baby's going to be your best friend. You're going to need to get a meter, both a good multimeter and an amp probe. And you're going to have to learn what these meters are telling you. It's extremely important that you understand what to set them on and what it's telling you. You just can't do this work without one of these guys. And again, like I said, I'm going to tell you, you're going to need both a good multimeter and a good amp probe. If you don't already have both or you don't have a meter at all, I would really suggest that you start off with buying an amp probe. Just go get a good amp probe. That will do the vast majority of what you're going to need to know, especially as you're just getting started working on control panels. There's a lot of good meters out there. There's a lot of good brands and names and so forth. But I'll tell you, you can go buy one of these meters just about at any big box hardware store or any electrical supply house for that matter, and you can probably get a really good meter for less than $100. So the number one thing that you're going to need to do once you get a meter is just learn how to take some voltage readings, learn how to use the leads on the meter, learn how to maybe just go to an outlet in your house and practice and learn how to take a voltage reading. The next thing you're going to learn how to do with an amp probe is you're going to want to learn how to check amp draws. Amp draws is also very important. It's going to tell you if your pump's actually trying to work or working or not. So that's why I say start with an amp probe. You can do a lot of this stuff with a basic amp probe like it, but you will need a multimeter for certain things. Again, a meter is a tool. So you're going to need to know exactly how to use it. A meter is going to tell you exactly 100% sure that this part or component that you might be working on at a control panel is good or bad. There is no guessing. Again, there are so many things that you can do with a meter. It's going to help keep you safe and it's going to help make you an expert out in the field. In my opinion, this will be your number one tool. Next, again, along with safety, I feel it necessary to bring up lockout tagout. If you're just doing residential type work, you're probably never going to run across something like this. But as you start getting into larger jobs and larger commercial jobs, I imagine at some point you are definitely going to run across this. I'm not going to try to make you an expert on it, but let me just tell you real quickly, it's pretty much what it sounds like. It's a padlock and a tag. The tag is going to have your information on it. You're going to be the only one with a key to that padlock. And when you go to work on an electrical panel of any kind, you're going to lock out the power source that's feeding it. This is just going to ensure that no one but you can turn the power back onto that control panel. So there's not going to be any surprises. You're not going to get shocked or electrocuted. Again, it's just a really important safety thing. And like I said, you will run across this when you get into larger jobs, I'm quite sure. So again, one of the number one things here at Zoeller is safety. And it's one of our number one goals is to make sure that we send all of our employees home safe each day. And this is just one of the ways that we do that. And again, like I said, you will run into this someday. And I can't stress safety enough. So we're going to move on here. We're going to move on to control panels. And here in front of you, you will see we are looking at the Zoeller website. And we're looking here to find our standard line of control panels, which is what we're going to talk about primarily today. It's important to understand the basic options that are available to you, as well as the applications they are suited for. If you ever have any questions, please, 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 I'm going to say this multiple times today, but we are always happy to assist you by selecting the most appropriate panel or product for any application. What might be right for one job won't be right for the next. These aren't one size fits all. So it's important that you know your options. Going to the website, you can see a lot of this here. So let's just dive in and see if we can help give you a better understanding. So let's dig into this. What is a control panel? Is it just some sort of magical box with mysterious parts and pieces that just makes your pump do what you want it to do? I know there's probably a few of you out there that think, yeah, that's just about right. Well, let me go ahead and answer this for you. No, it's not. And as a matter of fact, it really couldn't be further from the truth. A control panel is a box filled with switches and relays and alternators, motor contactors, overloads, all kinds of simple little components that when they're wired together correctly, they're going to do exactly what you want them to do. It's going to work extremely reliable time after time, year after year if it's done correctly. They aren't really difficult, but such as many things in life, it takes some knowledge and some time and experience to get good with these things, and you can do it. So why would you need a control panel? You know, it's a good question. There's a lot of reasons you might need a control panel. It might just be as simple as that you are looking to put an alarm and control functions together in one simple package. It might be that you have a big pump that's, say, large horsepower and you need a control panel to operate it. It might be something like you just need manual operation or that function is desired, so you want to use a control panel. Perhaps you're going to be monitoring a big three-phase pump. That would be a reason you might need a control panel. Maybe you want an alternating duplex application. That would be a reason. You may have a pump that requires external starting components. Maybe another pump that's intrinsically safe for hazardous environment applications. Maybe it's just because somebody told you you needed one. There are so many needs and uses for control panels out there, I couldn't possibly name them all. But my challenge to you is for you to try to identify the reason that you need a control panel. If you can do that, that one simple piece of knowledge will help you more than you might realize. And it's going to help you and us make sure that we select the right control panel for you and your application. So in order to select the right control panel, there are obviously various pieces of information that are going to be needed to ensure that we get the right control panel for your job. We start by selecting the right pump or pumps that you need for your application first. Sometimes people don't quite understand why we want to start with the pumps first, but I think we can all make this make sense here pretty quickly. By selecting the pumps first, this will help us determine such things as voltage and phase. Sometimes the pump you need isn't available in 115 volts. Sometimes the pump you need will be a big three-phase pump that might be capable of moving hundreds, if not thousands of gallons a minute. Each and every pump is going to have its own set of electrical requirements. And we need to know what those requirements are before we can pick out the right panel. By selecting the pump for your application first, it's going to give us things like the full load amp draw. That's going to make sure that we get the right wiring size and right components built into the panel for you. The pump that you might need or select might have options on it, such as a seal fail circuit. It might require external thermal cutout protection. It might need overloads and components such as that. All of these things will need to be taken into consideration when selecting a control panel. Again, it is not one size fits all. So moving on from the pump characteristics, now we will consider the things that we need this control panel to be used for. So again, we're going to have to determine where is this panel going. Again, that was part of my challenge to you. Figure this out. Is this panel going to go indoors? Is it going to go outdoors? Is it possibly going to be a hazardous environment application? You'll want to consider if you're going to need any optional control panel features, maybe such as auxiliary dry contacts, maybe a lapse time meter, maybe an event counter, maybe a main disconnect, maybe an inner door. There could be lots and lots of different options that you may want or need for your application. You're also going to want to determine if this is a typical demand dose application. Sometimes we run into some where they are a time dose application. where they run on a timer. So again, we need to determine all that up front. When it comes to control panels, as you can see, there are many different possibilities. There's many different options. And again, as I've said before, what's right for one job just simply won't be right for the next. And again, like I said, I'm going to say this multiple times too, but please don't ever be afraid to ask for help when it comes to selecting a control panel or really anything for your application. At Zoeller, we are always here to help. Call our product support team members. I can promise you this, making that phone call and getting the right panel and the right products for your application up front is much easier than trying to fix it all on the back end. So let's do it right the first time. So I want to talk a little bit about some of the standard features with the Zoeller's standard line of control panels. These panels are typically going to contain features such as a motor contactor. It's typically going to have a circuit board. It's going to have what we call a HOA switch or a hand-off auto switch or switches in it. It's going to probably have a pump run light. It's definitely going to have schematics and field wiring diagrams. It's probably going to have an audible and visual alarm. And these panels are going to be available in both NEMA 1 for indoor locations and NEMA 4X for outdoor locations. Our control panels can be outfitted with a number of optional features that may include, again, elapsed time meters, event counters, maybe a flashing alarm beacon, maybe a latching alarm, condensation heaters, auto dialers, other NEMA control panel options, maybe a stainless steel version. Maybe it's an intrinsically safe model for a hazardous environment application. Again, the options that you might need is going to depend on your specific needs and your specific application. Please remember this when we are talking about control panels. We can build a custom control panel that's going to meet anything that your local designer or engineer can dream up. Please don't ever be afraid to contact us. Give us a call. If you don't see something here, we haven't talked about it, if you've got somebody out there that's dreaming something up, we can probably make it happen. Like I said, when it comes to control panels, just about anything that somebody can dream up can be made to happen. So don't forget that, and don't be afraid to contact us. Please, please, please reach out. So we're going to talk about components. Instead of just talking about control panels and standard line stuff and what we might have to offer, let's just jump in right into the heart of the control panel and see how it works. Let's look at some of the components that you will find in a control panel. We're going to talk about these different components, how they work, what they do, and kind of learn about that. So with that, I'll ask you, what do you think the real brain of a control panel is? I'm going to say relays. Does anybody know what relays do? Well, these guys, they are super simple little components, yet they're going to get wired in ways that are just going to make your head spin. They're super simple, yet can be very complicated. They come in different shapes, sizes, voltage, amp ratings, but when it comes down to the end of the day, a relay is simply a device that has contacts inside of it, and they just open and close. That's it. It's just open, closed. Maybe think of it like a light switch in your house. You flip that light switch on, the light comes on. You flip it again, the light switch goes off, or the light goes off. That's just what relays do, but in an automatic sort of way. They are what gives your control panel its logic on what it does and when it does it. These guys have what's called a coil inside of them. And when voltage is applied to that coil, it is energized and it creates an electromagnet. And when that electromagnet is, like I said, when voltage is applied, that magnet comes on and it will pull that contact from whatever position it's in to the opposite. So it might be a normally open position and I might pull it to a normally closed position, or vice versa. Again, just think of it as on and off. That's all they're going to do. It's never going to change. That's what function they perform. Relays can have multiple contacts inside of them. So they can be used in many different ways. Again, they're really very simple, but they can get complicated so quickly, it'll make your head spin. But these guys, they are the brains of your control panel. There is no magic. Here we see a simplex circuit board. Most all of our simplex control panels, or at least in the standard line, they have a circuit board inside of them. And this is really the heart of these control panels. This board is where you're going to wire up your 115 volt incoming power for your control and your alarms. You're going to wire up your float switches. All the relays that are needed here are soldered directly onto this little board. So there's no wiring or anything that's in between those parts and pieces there. The HOA switch is on there. But let's just take a closer look at this board and just look at where some of these features are and so forth. So let's start with the alarm fuse and the indicator light. So there's a fuse and a light there. So if we have power hooked up and the fuse is good, that little light is going to be on. So handy little feature. Next thing we'll look at is the green pump run light. So if your pump was operating, whether it was in hand mode or automatic, when the pump is running, that green light is going to be on, lets you know that it's operating. Next thing we're going to look at is the control fuse and the indicator light. Again, if we have power hooked up to this board and that fuse is good, that light's going to be on. Again, another little handy little feature. Another piece here is the auxiliary alarm relay and the terminal blocks here. These terminal blocks are where you're going to wire up your incoming power, your float switches, all that sort of stuff, all your field wiring. And then the last thing I'll point out is just the HOA switch. Again, this is your hand off and auto position. You'd be surprised the number of phone calls we get with people that think they have a control panel problem, and the problem is that they don't have that HOA switch in the correct position. So anyway, it's a handy little thing and pretty important. So let's go ahead and take a look at a duplex circuit board. You may notice this circuit board looks similar to the simplex board, but it just has a few additional things to it. Things such as, of course, now you're going to have two HOA switches, two pump run lights, as well as float indicator status lights, which are really handy, by the way. Circuit boards, again, they make things quick, simple, and easy. There's, like I said, there's no wiring between the parts. They're all soldered onto the board. So let's just take a look at this one and look at some of the features on this. This control board starts off here with an on-off switch. So again, if you're out there working in the field, this on-off switch can be your friend. You can shut the power off right there. Next thing we're going to look at is the pump run lights, and just see that we have two of them here. And if you look closely on that board, it'll actually tell you pump 1 and pump 2. So you'll know exactly which pump is running and when. Next thing we'll look at are those HOA switches. Again, those are a 3-position switch because it's hand off and auto. So you want to make real important look there to make sure that they are in the correct position. Next thing we're going to look at is the control light and the control fuse. Again, it's just a handy little feature there. That light and that fuse, if that fuse is good and you have power to the panel, that light will be on. Just a quick, simple way to know. Next thing we'll look at is the terminal block here. So we have power and floats that both hook up here. Again, our incoming power, our 115 volt incoming power is going to hook up there, and then all of our floats are going to follow. The last thing we'll look at is the float indicator status. And these are just little lights there. So when your float switch comes up or closes, it will complete the circuit and that little light will come on. Again, it's a really handy little feature. It's just a nice addition there. I know I would use them out in the field. I could open up the control panel. I could see and have some idea where the water level was going to be when I opened up the pit just by looking at those lights. Also, if you ever had a bad float switch, you might be able to just simply look at that light and see that, hey, one of my float switches didn't come on. So you might know your float switch is bad by those. So again, really handy little things. Let's see, what else can I tell you about this? Again, let me just talk about circuit boards. Again, circuit boards make things quick and easy. They are truly a plug and play type thing. The downfall to circuit boards is if something fails on the board or gets burned up, you're going to have to get a new board. There aren't any quick fixes here that can be done. You're going to have to get a new board. So that means you're going to have to go back to the manufacturer or maybe your local distributor and purchase one. It's because of this that if you service many of these, I'm going to highly recommend that you get maybe both a simplex and a duplex, depending on what you work on, and keep them in stock. Keep it on your truck. This is probably the one component inside of a control panel that you just can't run down to a local electrical supply house and get. You're going to have to go back to the manufacturer and get one. And sometimes that might take a day or two, and that's really inconvenient for your customer. So again, this is the one component I would really recommend that you keep in stock. Like I said, the rest of the components that we're going to talk about here, you can probably go down to just about any electrical supply house in your area and get these parts. They are common items, just not the circuit boards. So the next thing I'm going to talk about is motor contactors. These guys are at the heart of most every control panel out there. Again, these guys are similar to relays, but they're made for turning on and off heavy loads, such as your pump. These guys have a coil inside of them again, and that coil, when energized, is going to pull your contacts in your motor contactor closed and turn your pump on. When the voltage is shut off to the coil, a spring is actually going to push those contacts back open. Because these turn on and off heavy loads, it does have heavy contacts inside of it, but every time that motor comes on or shuts off, there's going to be a little arc of electricity that happens each time. And over time, those contacts are going to wear out, the material on it is going to wear off, or maybe the coil will simply fail inside of the motor contactor. My point here is that eventually, someday, these are going to burn up. They're going to fail. They're going to need replaced. So again, this is a super simple little component. It's at the heart of just about every control panel out there. And again, it's a motor contactor and something you'll see. The next thing I want to talk about, typically you'll see it used in conjunction with your motor contactor, is an overload. Someday you might run into these, or you might run into people out there in the field that are going to refer to them as thermals or heaters or things like that, because that's how they function. That's how they're working. But it's what causes them to trip. And again, we just refer to them as an overload. So these overloads, they're going to have an amp range on them. Typically, it's got a little dial. It's usually under a plastic cover. Usually it's a clear plastic cover so you can see it. Most all of them that I'm aware of use a Phillips head screwdriver, and you're going to turn it to the appropriate amp range for your application. Like I said, you're going to adjust it to your amp range. If for some reason something happens, which someday it will, and your pump starts pulling more than the amps that you have selected on that dial, it's going to trip out and it's going to shut your pump off to protect your pump or other components. You might ask, well, I thought that's what a circuit breaker did. Well, it does. This is just a little device that helps us fine tune that. Circuit breakers only come in certain amp ranges. These guys are going to let you fine tune it to exactly what you need it to. Again, it's designed to save your pump. It's not there to be a nuisance. You're just going to have to learn how to use them and how to set them. I don't know, some of you may have been here to Zoeller at some point or may have heard me talk before. One of the things that I preach a lot is that heat is the killer of the electric motor. Again, these overloads aren't there to be a nuisance. They are there to protect your pump and protect your system. When these things trip out, they're doing it for a reason. So again, we want to keep heat from building up in the motor. And as those amps go up, amps equate to heat, and heat's the killer of the electric motor. So we want to shut that pump off as soon as we know that there's a problem. So now I want to tell you a little bit about setting these things. I'm going to give you the standard answer here. The standard answer is to set these for the full load amp range of your pump. Now, as you learn more about these and have more experience with these guys, you're going to learn how cool they really are, but you're going to probably have some more questions. And when you do have questions about overloads and how to set them and that sort of thing, again, please feel free to reach out to our product support department. Give them a call. They are here to help you. So here is a motor contactor with an overload. I thought this was just a really good illustration. You can see that these two items are put together. A lot of times they would appear that they are one part. They are not. They are actually two. And again, I just thought this was a good illustration. I just happened to, do a Google search and found this on the internet. This one happens to be from electricaltechnology.org. And I just thought it did a nice job of showing a lot of the different things that you might need to know about a setup like this. For example, notice how there are numbers associated with all the places that you might hook up wires. Well, here's a little secret for you. All components have numbered terminals and are generally universal, no matter what brand you might have. You might recall seeing some of these numbers on wiring schematics in the past, or maybe even on components themselves, but those numbers are there for a reason. So again, if you aren't familiar with that, start paying attention to this, to these numbers and so forth. These are going to help you in the future. It's going to help you become a real expert on this stuff. I want you to know that if you can't get the exact same part, you might not be able to get the exact motor contactor that you have, the same brand or whatever. If you pay attention to this and learn about these and notice those numbers, you're going to start figuring out that you could go to electrical supply house, you could get a replacement part, and you could put it into this control panel and it would work exactly the same and function exactly the same as your other one did. Again, I would highly recommend to start looking up all these components on the internet as you have time. There's a lot of great YouTube videos out there. It's going to increase your knowledge about this stuff exponentially. You're going to learn things that you could have never imagined before. It will take what you might have assumed was magic out of the control panel, and it's going to really help you learn the logic behind how these things really work. So here's another part I want to talk about, a capacitor. Anytime you have a single phase pump, it's possible that you might have a capacitor. And the reason I want to talk about these is this is probably the most dangerous part that you can find in a control panel. Now let me explain why. On a single phase pump, even small ones, it is common to have a capacitor that's going to help with the start and maybe even another to keep it running. But a capacitor simply stores and boosts the electricity to give the motor a kick, so to speak. It might be to get it started and or to keep it running. But the key words there were stores and boosts electricity. And this is why I say these guys are probably the most dangerous component in a control panel. They must be treated with respect. You're going to need to learn how to safely discharge a capacitor. That's a lesson for another day right now. So again, capacitors, they're rated in what is called microfarads, or as you might be able to see here on this one, as MFDs. In this example, you can see this capacitor is a 45 microfarad capacitor. It is very important if you replace a capacitor, you get one with the same ratings. So, another important fact about capacitors, they have a service life and they will go bad. Capacitors hate starting and stopping. So if you have a pump that has capacitors, it is extra important that you make sure you have a good pump run time by setting your float switches properly. If you purchase a new pump, one of our larger pumps, single phase, it is going to come with a box taped to it generally that's going to have a start capacitor, a run capacitor, and a relay inside of it. We recommend that you change out these components every time you change out the pump. Again, these things have a service life. They do go bad. This is a really silly way to burn up a brand new pump, and yet it happens. So again, if there was a part inside of a control panel that I want you to use extra caution around, it's these guys. Again, a capacitor can store electricity. So even after the power is shut off, you could still get a zap, a big zap from one of these guys. You really want to seek out more information about capacitors as you progress in your control panel expertise. Sometimes when a capacitor fails, it blows up and it makes a spectacular explosion, as you can see here. Like I said, these guys can be dangerous. I think this picture alone is enough to show you that you do not want to be working in a control panel when something goes wrong with the capacitor. Now, all this to say how dangerous they are when one day you're going to find one bad. You may not even be able to hardly tell that there's anything wrong with it just by visually looking at it. It can be very, very difficult to tell. But here's another tip. If you're visually looking at a capacitor, if you see that it leaks some oil, sometimes it might just be a little drip of oil that's, maybe on the capacitor itself. Maybe it's dripped off and it's in the bottom of the control panel and you see a little oil there. Take a really close look at those capacitors. Sometimes, like I said, when they fail, it's not a spectacular explosion. It might just be a little something and oil leaks out of them. So if the oil leaks out, that means your capacitor is bad. You're going to have to replace it. Something else I might mention is that, when you're looking at multimeters and that sort of stuff, you can get meters that read microfarads. So if you bought a multimeter that could read microfarads, you would know for sure if these are good or bad. But again, use extreme caution around capacitors. Make sure to get some training on them before you just jump right in and start messing with them. Okay, I want to talk about a multi-tap transformer. On many of our three-phase panels, you're going to find what's called a multi-tap transformer installed. This makes our panels very versatile, makes them able to be used in a variety of three-phase voltages. All this guy simply does is it steps down the voltage. So whatever voltage, whatever three-phase voltage you might be using, maybe it's 460 volt three-phase, by tapping this or by placing this wire on the correct terminals, what we refer to as tapping it, you're going to get 115 volts out of it. So why is that important? Well, all of the components that we've talked about in our control panels anyway, typically operate on 115 volts. So again, it's very important if you have a multi-tap transformer in your control panel that you make sure you know what that incoming voltage really is and that you make sure you tap this multi-tap transformer on the correct terminal there to get 115 volts out of it. If you don't do that, if you don't get it tapped correctly, if you just sometimes assume that you know and tap it to what you think and it's not right, you will damage components inside of the control panel. And again, the only way you're going to be able to fix that is by purchasing and replacing parts in the control panel, not the way you want to learn. Another thing that I want to mention here is the fact that these transformers have fuses. These fuses are very specific fuses that go in these guys, and they are very expensive, maybe $50 a fuse. So again, you want to make sure things are wired right before you turn on the power. Take an extra minute or two and just double check things. Like I said, use your meter, it's your friend. Make sure you know what that incoming voltage is. You want to get this right. You don't want to make a mistake here. And again, as I've said before, and I'll say a number of times today, please feel free to call our 1-800 number and talk to our product support members. They are here for that extra reassurance that you need. They can help you make sure that you're getting it tapped in the correct place. So please reach out to them. The next thing that I want to mention here is these intrinsically safe modules. These are going to be used in what we call a hazardous environment location. Sometimes people refer to that as explosion proof. These will officially be called out as Class 1, Division 1, Group C and D locations, or another rating is Class 1, Zone 1, Groups 2A and 2B. So an intrinsically safe module, they may look different. There's different types out there, and even in our control panels, you might get one that looks a little different than this. This is probably the most common one we use at the moment. But again, what this guy does is it is going to step voltage down so low, and this is going to be going to your float switches, the wiring to your float switches. It's going to step the voltage down so low that even if you had an environment down in your pit that was full of explosive gases of some sort, that even if, say, one of these float wires got cut or nicked or even shorted out down there, they could not produce a spark hot enough to ignite the gases. So obviously this is a very important thing. Another big thing to remember is that high voltage, like going to your pump, and low voltage, in this particular case, these going to our float switches, they do not mix. They must stay separated. And they're, according to National Electric Code or NEC, they must be separated. And that's why you find this barrier that you can see here around this module, or where the wiring hooks up to this module. Just running your high voltage wires within a few inches of your low voltage wires can cause catastrophic failures. Again, this is very important. You should always run your high voltage wires, like I said, going to your pump, and your low voltage wires in situations like this in separate conduits. Running them together is never allowed and not recommended. All right, since we've talked a little bit about three-phase, I want to mention this about three-phase monitors. Here's a couple different three-phase monitors that can be installed in a control panel. These monitors, they will monitor for a loss of a phase or a voltage drop or things like that. I think these guys are really awesome. They can help save a pump from being burned up. For example, I've been out on job sites and seen a pump burned up because this facility may have lost a phase. Sometimes that happens in the middle of the night. Maybe nobody thinks any of the equipment is working, but if the lift station is called to come on, your pumps are, and if you're missing a phase for whatever reason, that pump is going to try to run, and it's going to be trying to run on just 2 phases of power instead of 3. And it, again, very likely to burn your pump up. Or sometimes you might have an electrical loss or a drop on one of your phases, or all of them for that matter. These guys are going to monitor all that. So again, we start talking about 3-phase pumps, we start talking about expensive pumps typically. I would highly recommend considering one of these devices. Otherwise, you might find yourself being blamed for a burned up pump. And again, nobody might have even known that they'd lost a phase. But if you had one of these guys in your control panel, not only would you have known that you'd lost a phase, but you would have prevented burning up that expensive pump. So I can't say enough good things about these guys. So let's start putting some of these parts and pieces together that we've discussed now, and let's create an actual control panel. And let's just start with one of our simple simplex control panels. And I guess for anyone that's new out there who may not understand that term simplex, it simply means one pump, just one pump is being controlled. So let's take a look at some control panels here, some simplex single phase control panel. So right here, you see again, a simplex single phase panel. This is one of our most basic panels. I want to point out here, you will see a circuit breaker. It's where our main power is coming in. You will also see the circuit board that we discussed a little bit earlier here. You're going to see the test normal silence switch that's mounted on the side of the control panel. You're also going to see a motor contactor in here. And again, you might notice this motor contactor looks a little bit different than the ones we were looking at earlier. Again, it performs the same function, does exactly the same thing. So, next one. This is a simplex single phase panel. This one is typically used with our grinder pumps. It could also be for a larger horsepower single phase pump, but let's look at some of the things inside this control panel. Again, we're going to see a motor contactor and actually even an overload there connected with it. We're going to see a circuit breaker we're looking at. And then the next thing I'm pointing out is the motor start kit. This is our start capacitor, our run capacitor, and our relay. And that's probably one of the biggest differences here between this control panel and the other we looked at. Another feature that I did not point out here is this one actually has a seal fail, which is the little red light there on the side, that little white board there. Another thing you might notice about this control panel is that the circuit board that we've looked at and spoken about, it's orientated differently. It's actually up and down instead of, or vertically instead of horizontally. So let's look at another panel. Here you will see an intrinsically safe simplex control panel. Again, this type of control panel is going to be used with a hazardous environment pump. That's the intrinsically safe module that you see there that we just spoke about. And the rest of the components in here look very similar to others that we've seen in the other slides and of course at the beginning. But let's take a closer look at this one. This one has optional seal fail module and remote lights that are through the front of the panel door there. It has a test normal silence switch that's on that far side here. Just another little tidbit for you. I like those test normal silence switches there. It has obviously a test position there. It's a spring-loaded switch, and if you flip that to the test position, that should set off your audible and visible alarms. When I would walk up to a control panel that maybe I was getting ready to open up or work on, sometimes I would just give that switch a little flip and see if the alarm went off. If it went off, then I knew at least we had power going to that control panel. If it didn't, then I knew we were probably in for something a little bigger. So next thing we'll look at here is the circuit breaker. Again, this is the circuit breaker for our pump. Next thing is the motor contactor. Next thing I'm going to point out is that intrinsically safe barrier. Again, I spoke about that earlier. That's very important. You'll want to actually run a conduit in on the inside of that barrier for your low voltage wires, and then you would want to run a conduit in on the other side for your high voltage wires. I've had people come in here that didn't understand intrinsically safe barriers and what they were for, and they tell me, oh, I didn't know what that was for, so the first thing I did was take the screws out of it and take it out and throw it away. Don't do that. Learn what it's there for and keep it there. The next thing I'm going to point out again is just the intrinsically safe module itself. So let's move on. Let's look at another control panel. So this control panel is a simplex panel. It is used for a three-phase power application here. This one you can tell looks quite a bit different than the ones we've seen so far. This one does not have a control board in it. It does have that multi-tap transformer that we spoke about earlier. But let's look at some of the other components in there as well. Well, let's just start off. Let's look at the multi-tap transformer there. Let's look at the motor protective switches here. Again, these guys look a whole lot bigger and a whole lot different than the ones we looked at earlier. Again, they perform the exact same function. The next thing we'll look at is just the terminal block. This is where your incoming power would go, your field wiring for your pump and your float switches. You might have some auxiliary contacts of some sort in there, maybe a pump run, a high water alarm. There could be a number of different relays in there. And again, your wiring schematic on the door is going to be what tells you that. The last thing I'm going to point out is the motor contactor. And again, it looks quite a bit different than what we looked at previously. Even though these components look different, they work exactly the same. This particular control panel, I see one relay in there. I'm not sure what this panel was designed and built for. This is a custom built panel. You can see it's in a stainless steel enclosure. You can see it's got some lights and switches that are actually through the front of the door. And this one actually has a main disconnect through the front of the door as well. So it'll have a big handle out there, and that would be used to shut the power off before you can open the control panel door. Again, this is all about safety, and that's why that option was probably chosen here, is to shut the power off before we open that control panel door. Again, Here at Zoeller, we can custom build a control panel for just about anything your designer or engineer might be able to dream up. And for you guys out in the field, and when you run across these, I mean, no, control panels are going to look very different inside sometimes. It's important to understand the use, and it's important to know where that wiring schematic is. It's going to point you in the right direction. It's going to make sure that you know where to hook things up and things like that. But again, if you ever run across a control panel that maybe looks a little different to you, doesn't look quite the same, again, call our 1-800 number, call our product support folks, give them the part number of what the control panel is, or whatever the Zoeller product is that you have. Give that to them and they can look it up. They can help you. So let's review for a minute. If you're buying a standard off-the-shelf simplex control panel from Zoeller, it's more than likely going to come with 3 float switches. So I just want to go over how this should operate in the field. So these next few slides here, we're going to try to help illustrate how a typical simplex control panel will normally operate. In this particular example, we have weighted control floats. And in this sump pit, you can see that we have 1 pump. You can see our water level there in gray, and it has not yet risen high enough to activate any of the float switches. So let's run through this. Water starts coming into the pit. The first float, our stop float, is activated. Nothing happens. Water continues to come into the pit. Now, as the water level rises high enough, our start float switch is raised. Now, when this happens, it calls for the pump to be activated, and the pump begins pumping the water level down. So you can see here, the pump is discharging the water. The start float has dropped out. Notice the pump continues running and continues discharging water. The pump will continue to run until the stop float drops out and tells the panel to shut the pump off. This is a normal pumping cycle. So let's run through this again. So water begins to rise in the pit. The stop float is activated. Nothing happens. The start float is again activated. The pump begins to pump water once again. But this time, let's say the flow that was coming in, the flow of water that was coming into this pit was so great that the pump couldn't keep up with that flow. So now the water level has risen high enough to activate the high level alarm switch this time. You will now have your audible and visible alarm features activated on your control panel if it is so equipped. This will alert the user of a potential problem. But since we have a trusty Zoeller pump in here and the flow of our water coming in has slowed up a little bit, our trusty Zoeller pump is able to catch up and discharge the water. So now water is going down. You can see our alarm float dropped out. And when our alarm float dropped out, our audible and visible indicators were shut off. And the pump stays running and it's going to continue to pump down the water. Again, you can see here now our start float has dropped back out. The pump is still running. And lastly, now the stop float has dropped out and we have completed our pumping cycle. This control panel, it's shut off. It's ready for the next cycle. I want to stop right here and just ask you, can you think of any common mistakes here, something that could go wrong here? I'll tell you one is that when people put in a control panel and float switches, a lot of times they don't think it's important or don't take the time to mark the wires on the float switches. And if they mess up the order of those float switches, and as long as they don't get the alarm hooked up to the stop or the start switch, this panel is still going to operate, but it's not going to operate correctly. So think about it. If we flip-flopped or switched the location of our stop float and our start float, what would happen? Like I said, it will still operate. The pump's going to come on, but in a situation like this, it's only going to operate the pump based off the movement of one float switch. Therefore, it's going to short cycle your pump. Like I said, this is a common mistake that we see, and unfortunately, it generally leads to a premature pump failure. So when you're out in the field, my little tip here to you is to physically activate each of these float switches. One, make sure they are installed in the correct location and make sure they're working as they should. I feel like this is really, it's so simple, but yet these kind of mistakes happen all the time. And these are the little details that are going to make you the real expert. So let's move on to duplex control panels. Again, for anybody that's new out there, doesn't understand what the term duplex is referring to, we're referring to two pumps. It's a two-pump system. Pumps in these systems are typically alternating, so each take a turn running. Generally in these panels, both pumps could be called to run at the same time if needed. Because of this, these panels will typically require an additional electrical circuit, which can be very important to make sure you get that addressed ahead of time. So let's just take a look at some duplex control panels and see what's different. So here we see a basic duplex control panel. You're going to notice that this panel right off the bat has that duplex control board that we spoke about earlier, as well as some additional components. So let's take a closer look here. First thing we're going to look at is the motor contactors. We have two motor contactors, and again, these motor contactors look a little bit different than anything else we've seen so far today. Again, they do exactly the same thing. The next thing I want to point out is we now have two circuit breakers. We have two circuit breakers, one for each of our pumps. The last thing that I'll point out on this particular control panel is the wiring schematic. All of our control panels are going to have a wiring schematic in the door. These wiring schematics are your friend. You need to make sure you look at them. They are going to tell you where you need to hook up your incoming power. They're going to tell you where you need to hook up your floats. They're going to tell you where you need to hook up your pumps. Very important things. Now we're going to look at a duplex three-phase control panel. Let's take a look at some of the components in this panel. Again, this control panel looks a little bit different than some of the others we've seen so far. This panel has a seal fail module in it with indicator lights through the front door. In order to utilize this, you're going to have a pump with that seal fail option. Again, this is why we want to identify which pump you're using ahead of time before we figure out the control panel to make sure we get these kind of options in there that you might need for your pump. Again, this is a three-phase panel, so this particular panel has that multi-tap transformer in it. Again, we need to make sure that we tap it correctly. Again, it's going to make this panel much more versatile for use with varying three-phase voltages. This panel has the motor protective switches with the overloads. Now, these look a little bit different than what we looked at previously. These actually have a little roll knob, and that is your circuit breaker and your overload all in one device there. So it's going to have a little clear plastic window there. It's going to have a dial on it. You're going to have to turn those dials to your full load amp draw of your pump. But again, guess what? From panel to panel, parts are going to look different, but their operation is going to be the same. Let's look here and go through these just so you can actually see them. The seal fail modules that I spoke of, here they are. We're going to look at the multi-tap transformer. There it is in the top corner. These motor protective switches that I mentioned, those are those little roll knobs that I was talking about. They just turn either straight up or they are 90 degrees over. Right now, these are in the off position, it looks like. If they were straight up, they would be turned on. If they tripped for some reason, they would be at like a 45-degree angle there. And then lastly, right below that is the motor contactors. So let's move on. Let's look at another control panel. Here's a custom three-phase panel. This one is in a stainless steel control enclosure. This one does not use a circuit board. You can see there's a number of relays across the top there. So this is using good old-fashioned relays for hardwired logic. It's very possible you're going to run into an engineer out there that prefers this type of system. And the reason he does is because it doesn't have a control board in it, doesn't have a circuit board. With relays performing the logic like this, there's more wiring, there's more components. But again, these are all off-the-shelf type items that you could go to any electrical supply house and get. And that's generally why designers or engineers, when they select something like this or spec something like this, it's probably for that reason. They want to make sure that the components are easily accessible. So again, let's just talk about some of the other options that I see on this one. This one has a main disconnect that goes through the panel door. It actually's got a little lever there that's on that main circuit breaker that's turning it on and off. And again, the reason why your engineer or designer might call for an option like that is it's all about safety. And they want you to have to turn power off to this control panel before you can open the door. And again, this one has a multi-tap transformer, which we've discussed. A lot of the other components, again, they look a little different. They might be a whole lot bigger, but they do exactly the same function as all the others that we have talked about. Again, control panels are going to look different. They are not one size fits all. They're all going to look different, but at the heart of these control panels, they all function the same. The components might look different, but they function exactly the same. So now I want to go through, again, if we're talking about a standard Zoeller duplex control panel, again, they generally come with 3 float switches. And I want to just go through how a duplex control panel might work with 3 float switches. So let's look at these next few illustrations here and just discuss this. So you can see that we have a duplex panel here. We have 2 pumps down in the pit, and we have 3 weighted float switches here. So to begin, we're going to have some water start coming into the pit. As the water comes in, you're going to see now the stop float has risen. Water continues to come into the pit, and now our start float, or now what we're referring to as the lead float switch, is activated. And when that happens, pump 1 comes on and water is being discharged. So pump 1 runs until the water is discharged to such a point that the stop float drops out. And when it does, the control panel shuts off the pumps and it's ready for the next pumping cycle. So let's go through it again. Now this time the water level comes in, the stop float comes up. As water level continues to rise, we now activate our start or our lead float. And as it's activated, we can see that because this is a alternating duplex control panel, that this time it has alternated and is now called for pump 2 to come on. Pump 2 is referred to as our lead pump in this particular scenario here. And that's why we refer to that start float as our lead float. It is going to call for the next pump in the sequence to come on. So if it's a duplex operation, it's going to call for pump 1 and then pump 2, pump 1 and then pump 2. And it's going to do that, like I said, again and again, over and over. So in this particular example right now, we see pump 2 is our lead pump, pump 2 is on, and it begins discharging water. Pump 2 is going to run and pump out water until that stop float drops out again. And when it does, it's going to shut off and it's going to be ready for the next pumping cycle. We'll go through it again. As water comes into this pit, the stop float rises, the lead float is activated, and pump 1, because pump 1 is our lead float this time, or our lead pump this time, is going to come into action. Now in this example, I'm going to say that pump 1 was not able to keep up with the water flow that was coming in. It was an unusually high incoming water flow rate. So the water continued to raise, and it raised in this pit until it has reached our lag/alarm float switch. Now at this point, when this float switch is activated, 2 things have happened. The high water audible alarm and visible alarm have been activated, and pump 2, our lag pump now, has been called into action. So we have a lead pump and a lag pump in a duplex system. Whichever pump is running is our lead pump, and when, like I said, this lag float comes up, it calls for our additional pump to come on, and in this case it was pump 2. So now both pumps have been activated, both pumps are running. Now with both pumps running, now we're able to make a little headway on the water flow coming into this pit. And as we do, the float switches start to drop. The lag/alarm float switch has dropped out. Our audible and visible indicators on the control panel have been deactivated. Both pumps continue to run. And right now our lead float has dropped out, but both pumps stay running all the way until the stop float drops out and we are back to a normal water level and we are ready for the next pumping cycle. So that's just kind of the operation of a 3-float duplex control panel. So now all of Zoeller's duplex control panels can be wired up to accept 4 float switches. Sometimes people think that a 4-float setup is better and preferred over a 3-float setup. Sometimes it is, and sometimes it isn't. But let's just go through a 4-float operation and talk about this. So, as you notice here, we have a duplex pump setup, and we have it wired up with 4 weighted float switches in this particular application here. What you will notice is we have separated out the alarm and the lag functions onto their own float switches this time. That's the difference between a 3-float and a 4-float system. So what I want you to also note here is that I have opted to set my alarm float before my lag float. Now, depending on the wiring schematic that you might have, it might tell you to set it up opposite of that. I'm going to do it this way, and I'm going to run through this operation and discuss why I think you should at least consider wiring them up this way. So let's run through it. So water level begins to rise. Stop float comes up. Nothing happens. Water level increases some more in the pit. It reaches our lead float. Pump 1 is activated. Pump 1 begins pumping the water out of the pit. The lead float drops out. Our stop float drops out. And we are now back to a normal water level. We're ready for the next pumping cycle. So here we go again. Water's coming in. Stop float goes up. The lead float now goes up. When the lead float goes up, again, it's going to call for the other pump or whichever one is next in line, our lead pump to come on. In this case, it's pump 2. Pump 2 begins pumping and discharging water. As pump 2 discharges the water, it's going to again run until the stop float drops out and shuts the system off and again, ready for another pumping cycle. So now let's get into the real differences here. This time water comes in, and let's just say again that water's coming in at a much higher flow rate than normal. So as it's coming in, the stop float comes up, the lead float rises, and when it does, it calls for pump 1, or our lead pump this time, to come on. It begins pumping. Again, we've said that the water is coming in so fast this time that pump 1 was not able to keep up with the flow rate. So the water level has risen to such a point now that it has activated, in my setup here, the alarm float. And I have chosen to do this way, and I want to explain. So what's happened here? Well, pump 1 is running. It's not keeping up with the flow. Our alarm has been activated. So now our audible and visible alarms are both on. Notice pump 2 has not been called into action yet. With a float setup such as this, there's going to be a period of time where you would have an alarm situation. This will alert the user that something might not be right, and it will give them a little bit of time to try to determine what's going on or what to do. It could simply be because there was a higher than normal water flow rate coming into this pit. Maybe this is on a house. Maybe somebody has a big giant jacuzzi tub up in their master bedroom and they've just drained it and it's coming pouring in here faster than the pumps could keep up. But again, the thing that I want to point out to you is that I have opted to put my alarm before my lag float. And the reason I have done that, if you think about this, if I had put my lag float before my alarm, what would have happened? Well, pump 2 would have been called to operate. It would have come on, maybe it would have taken care of the situation. But the problem with that is that maybe there was a problem with pump 1. Maybe that's why it wasn't working or keeping up with the flow. And in that arrangement where we have our lag and then our high water alarm, nobody knows that there was a problem or a potential problem with one of the pumps. There would have not been an audible and visible alarm go off. Let's just say pump 1 was bad. If it was bad, nobody would have ever known. And I am unfortunately have been out to job sites and seen that where a pump has failed. They never knew about it until eventually the second pump failed. And now when the second pump has failed, now they're dead in the water. Generally, they are not happy campers when you tell them they have not only one bad pump, but two bad pumps. And to top it off, they are dead in the water. They have no pumps. So like I said, this is a float arrangement that I just want you to think about. I want you to understand. I want you to get the idea of why I've opted to do that. It might not be right for every situation out there. I've just clicked on to the next slide here. You can see in this slide, the lag float has now come up, and that's when it calls for pump 2 to come on. And so now both pumps are working together. Again, this float arrangement, like I said, it might not be right for every system out there, but I just want you to get that idea and understand this. To me, this is what's going to make you the professional. It's going to make you the expert out in the field. It's going to allow you to make the best decision for your customer. So just to finish this off here, with both pumps running now, we begin to make headway on the water flow that was coming into this pit. As the water level drops, now our alarm float is dropped out, and when it does, our audible and visible alarm is deactivated. And the water level continues to pump down with both pumps running together. So even after the lead float drops out, they're still running together. Eventually, we get back to the point where our stop float drops out, and when it does, we have completed that pumping cycle and the system is back to normal. It's ready for the next pumping cycle, or it'll call for the next pump to come on again. So I hope this gives you a better understanding of how our standard control panels typically work. As you've been able to see here, there are some differences both between simplex and duplex control panels and 3 and 4 float setups. Remember, each application is different. Selecting the right equipment and the proper setup for your application is key. And that was my challenge to you in the beginning of this, is to try to figure out and determine why you need a control panel. Understanding these differences and seeing these illustrations, hopefully that has helped you get a better visualization and understanding and allows you to become a better professional in the industry. So now at this point, I just want to go over some little troubleshooting tips here. And depending on your situation, these might be really good tips for you. So let's just start with the first one. The first one is to use a multimeter and check the actual voltage. Again, I've mentioned this throughout this presentation today. There's many a times when you're going to need to check voltage. Sometimes you're going to need to check it to make sure that you have voltage. Sometimes you're going to need to check it to make sure you don't. If you're having a problem with a panel and you think it might be a voltage issue, maybe you think there might be a problem with a component inside the panel, get out your multimeter or your amp probe, put it on voltage, and check the voltage. Check it as close to the pump as possible. That will help you make sure that it's not a component in the panel. When you're doing this, if you have an amp probe, be sure to check that amp draw too. So that's probably my first tip. Use your meters. They are your friend. They are probably your best tool, so use them. Next thing I want to mention, again, talking about those float switches there, make sure that you activate those float switches. Again, I said before, I would always physically manipulate them, whether you're using a rod of some sort to lift those float switches up down in the pit, or whether you put a pair of rubber gloves on and pull those floats up and actually manually manipulate them, but manipulate them in the order that they're supposed to come on, and check and see, make sure they're installed correctly, make sure they're wired up correctly, make sure they're working correctly. Next thing I want to mention is to perform a drawdown test for each pump in your system. Make sure they're performing as expected. I'm going to talk just a little bit more, and as we finish up this presentation, you're going to see that there's some attachments attached, and there's going to be more information on how to do a drawdown test and how you do that. But basically, a functional drawdown test is one where we are going to put water in the pit. We are going to activate a pump, ideally for 1 minute, and we're going to run that pump. We are going to shut it off after 1 minute's time, and then we are going to measure and figure out exactly how much water we got rid of And based on that, we'll be able to look at a pump curve for that particular pump, and we will be able to determine exactly how many gallons per minute we got rid of and where that pump is running at on the pump curve. To me, this was a great troubleshooting tip out in the field. Sometimes when people had problems, maybe they're burning up pumps and they don't know why. Maybe there's just some issue. Maybe it's downstream from their equipment. But by doing a physical drawdown test, you're going to know exactly how those pumps are performing. Maybe you have a job where an engineer has specified a specific design point and flow rate. And again, this is your way to make sure that after it's all said and done, what the engineer calculated is really right. So again, a drawdown test, I think, is a really great troubleshooting tip. Another troubleshooting tip that I want to give you is if you have a duplex system, if you have a problem with one of the pumps, try switching the wiring in the control panel. Flip-flop the wires between pump 1 and pump 2. So physically hook up pump 2 where pump 1 was and hook up pump 1 where pump 2 was. Try it. Try running the system again. This is going to help you determine for sure if you have a control panel problem or if maybe you have a pump problem. In troubleshooting, you kind of have to determine where that midway point is in your system, and you're going to have to cut it in half and separate it and figure out which direction the problem is. That's going to give you a clue as to which way to go. Are we looking in the control panel or do we need to look in the pit? This is one of the just a quick and easy way that you can do that. Flip-flop pump 1 and pump 2. Try it. See which one, does the problem stay with the pump that it was originally with? Does it stay with pump 1? Or did it now change and now it's pump 2? Again, it's going to tell you where the problem's at. Is it in the control panel? Is it with the pump? And the last tip that I'm going to leave you with here is don't be afraid to use your phone. By now you know who to call. Call us. We're here to help. In the last few slides, I just want to go over some items that I felt like are worth noting that really help make a system the best that it can be, that can make it long lasting. So the first one I want to talk about is a junction box. Junction boxes, we don't like to recommend them. Just as the name indicates, they are another junction. They are another splice. It's where all your wiring is going to come together and is probably wire nutted together or reconnected in some form or fashion. Sometimes you have to use a junction box, and it's okay. You can use them. You just, again, want to make sure that you do it in the best possible way. And one of the best possible ways that you might do that is if you could actually locate the junction box just outside of the pit, that might be preferred. But again, it might not always be possible. So in order to do it, let's make sure we do it right. And so let's discuss the next item up here. And that next item is a cord grip. These are vital in many applications, but especially ones with junction boxes, and even more so if you have a junction box in a pit. So what's the cord grip? Well, it is simply a little plastic piece in this particular case. It has a rubber bushing inside of it, and it has a nut there on the outside. And as you tighten up that nut, you actually compress that rubber bushing that's in there, and it will compress around the cord of whatever it is that you're putting it on, whether it's a pump power cord, a float, sensor cable, whatever it might be. But it's going to compress around that cable, and it is going to form a good solid connection to keep hopefully any moisture and gases and those types of things out of the junction box. So again, very important. Now, the one thing I want to point out about cord grips is they do come in different sizes. So make sure you get the correct cord grip for the diameter of your power cord or cables that you're using. So important tip there. And like I said, if you're using a pump in a pit and you don't use a junction box and you just perhaps pull the cable up there and maybe put some wire nuts on it and some black electrical tape, this is what can actually happen. This is a good reason why you need to use those cord grips. Many of our pump power cords can wick moisture, and they will wick moisture over time. And right here is exactly what can happen. You can see I have the cap of this pump off, and it is filled with water right up to the top of those through wall terminals with all the electrical wires connected. So when water finally gets up to that point, it's going to short out all of our electrical connections. People typically think that their pump is bad. It may or may not be. But again, just by not using a cord grip, this was a silly and very expensive mistake. So good news is that all Zoeller pumps are built. If this should happen, you can replace the might be just the power cord, might be the cap and cord assembly, but you can replace it and fix it, and you could put this pump right back in service. So again, make sure you use cord grips. Next thing I want to mention is silicone filled wire nuts. These are just a good practice to use, especially in junction box applications. We like to recommend them whenever possible. Trust me, I did electrical work before I came to work for Zoeller. I was used to just standard wire nuts. I hated using these silicone filled wire nuts when I first started using them. But over the years, I began to see some real benefits to using these wire nuts. I learned that it's not so much about keeping the moisture out of the actual connection, because if you've got moisture or water in there, it's probably wicking down your cords, and your electrical connection's probably not your biggest concern. But at some point, you're going to find that you're going to have gases, sewer gases in these pits. And those sewer gases can get into these junction boxes. And that's probably the biggest advantage I saw to silicone filled wire nuts, is that they can help keep your connection clean. They can keep the wire, and I don't know if you're familiar with a wire nut, but a typical wire nut has like a little spring in it, and you have two pieces typically of copper wire that you put together, and you twist that little wire nut or that spring over them, and it makes a good tight connection that can last for a long time. But again, with a standard wire nut, you get just gases in there, and they will deteriorate over time. I've been to more than one job site where I've seen standard wire nuts actually burned or melted off, and I have seen very expensive pumps burned up because of a poor electrical connection or a bad wire net connection, or one where these sewer gases simply got to a standard wire nut and it eroded or corroded away, and we lost a phase, we lost a connection, and the pump could not operate on the proper voltage, and we burned the pump up. So again, there are a lot of good reasons to use these silicone filled wire nuts. I think they're a superior system. I think that you should make this your standard practice and use them. And I'll also tell you to just carry a roll of paper towels in your truck with you, because they can get messy. So silicone filled wire nuts, good practice to use. The next thing I want to mention, again, being to a number of job sites, I've seen a lot of different ways that people have tried to seal up conduits. So duct seal. Duct seal is what we recommend. Duct seal is different than plumber's putty. And as you can see, this duct seal, you can see the way it's spelled here. It is actually made for like air ducts. And this stuff will remain pliable forever. It will not dry rot or harden up like plumber's putty does. This is the proper way to seal up a control panel. If you've ever been out to a job site, at some point you're going to need to replace a pump. You're going to need to replace a float switch. And depending on how they've done it, it might be very difficult. But if they use duct seal, you can simply remove that duct seal. You can then pull in your new wire through your conduit or whatever you might have there. And then you can put your duct seal back and, replace that seal. I'll tell you, you don't ever want to use silicone. Silicone in a control panel can do some off-gassing and cause some problems of its own. And spray foam is another big one that I've seen so many times I can't count. Spray foam does a great job of sealing up the conduit. The problem with spray foam is you can't get your wires out when you do have to replace something in the future. And spray foam in a conduit can be an absolute nightmare to get it out. Sometimes you can't, and you just have to cut everything out and start over. Again, I feel like that is a really expensive, silly mistake to make. So use duct seal. Here's just an example of some duct seal packed around the incoming wires of this control panel. Again, I just wanted to illustrate that. Next thing I want to point out is these J-hooks. If you've worked around lift stations or pits in the past, you know that generally you want to keep some extra wire in that pit there. One reason for that is that you are going to need to pull that pump out perhaps and service it. If you don't have extra wire there in the pit, you very likely are not going to be able to get that pump out. There's nothing more frustrating than have to go unwire a pump from a control panel or a float switch and have to pull that wire out just to make a simple adjustment or a cleaning or something like that, and then have to fish it all back in. Having that extra cordage in the pit is definitely what you want. But what I want to point out about that is to please, please, please make sure you keep that extra cordage, those wires, up and out of the water. And these J-hooks are a great way to do that. You can't imagine how many times we get a pump back here at Zoeller and we find that the problem with it is that it got a hold of the pump power cord. Well, sorry, that's not a warranty situation. That's an installation error, not a manufacturing defect. So again, these J-hooks are great. I would highly recommend that you use them. Even if you have an additional float bracket or float pole or some type of system in there that your floats are tethered on, use these J-hooks. They're a great way to keep your cords, your waters, even your pull cables or ropes or whatever you might have tied to your pump. It's a great place to put all those things. And talking about pumps and servicing them, I thought this might just be a good slide to throw in there. A pump hoist. A pump hoist is going to save your back. It's going to save you from hurting yourself. As you get into bigger and bigger pumps, at some point, a pump hoist of some sort is going to become necessary. Now, maybe for you, that comes in the form of a big crane truck, and that's great. But there are going to be other pits where maybe you can't use a crane truck. You know, these pits sometimes get installed in basements or all kinds of strange locations. So having some type of mechanical system that you can use to hoist those pumps in and out of these pits in a safe manner is recommended. So again, no matter what you choose or find, make sure you get something that's safe, and remember that it's not worth hurting yourself over. Work smart. Another thing that I want to point out here, and this might be more of a troubleshooting tip, but if you have a three-phase pump, three-phase pumps can be wired up and can rotate in the wrong direction. So you'll want to make sure you check that your pump is in the correct rotation. At Zoeller, we try to make that really simple and easy. And as you can see here on this volute of this particular pump, we actually have the word rotation, and we have an arrow pointing in the correct rotation that impeller should be spinning. Again, it's very important that this is checked. The preferred way is, of course, to check rotation before you put the pump down in the pit. But if for some reason that can't happen or that didn't get done, I'm going to give you another little quick tip here. A way you can check this without pulling the pump is to shut off the power. And again, three-phase pumps are going to have 3 power leads going to the pump. If you switch any 2 of those 3 power leads, that pump is going to change rotation. So flip-flop 2 of them and try it. Use your amp probe and check it. So try it one way, turn the pump on, run it, check amp draw, and whichever way yields the lowest amp draw is generally correct. Again, this method might not work for every system out there, but it'll work in a lot. And at some point, that might be a good tip to save you. But again, the preferred method is always pull the pump out and physically check the rotation. Another one I want to bring up is trash. If you go to a big job site, a big commercial site, there's a hole in the floor in the mechanical room. Well, guess what? It becomes the trash bin for all of the trades. Everybody sweeps all their trash to the big hole in the floor. So if you got a situation like that, you're going to have to get that debris out of the pit. You do not want to start up a pump system with a bunch of trash in there. Plastic straws and things like that can cause problems for pumps. It could damage the seals on a pump, and it could be a really silly reason to have a pump failure. I know it's easier said than done, but you're going to have to get that pit cleaned out. You might have to go to the customer and tell them that they need to get it pumped out. But another, I guess, a little tidbit I can give you, if it's a new application like this, you might consider getting a pool skimmer on a long pole. It might be such that you can skim a lot of that trash out of the pit and still start it up. But just don't be afraid to ever have to go to your customer and tell them, look, we have to get this pit pumped out. It's a whole lot cheaper to spend a couple $100s on a pumping bill than it is to ruin a pump that might cost thousands of dollars. And if you're the one installing it, you don't want to ruin your good name. So that's probably the most important. So don't be afraid to go back and tell them they got to get their pit cleaned out. But lastly, I want to tell you to do a startup report. We just find when people do these, When they send them in, we look at them, we keep them in our files. If we notice a problem, trust me, we will call you and let you know what we see or what we think. And so you can go back out there to that job site and address those issues or double check things. Just by going through the motions of filling out a startup report, it's going to try to step you through step by step there. Make sure your float switches are set up good. Make sure your amp draws are right. Make sure the voltages are good. And again, just by going through that, that'll help you. I used to do this even with the smallest pumps I put in. I would a lot of times at least just go through a startup procedure to make sure I had crossed all my T's and dotted all my I's and made sure that I had a good working system there. It's all the little things that make the difference between a system that's just okay and has problems or a system that works fantastic and never has an issue. You can do it. So with this, I want to thank you for your attention today. I hope this has been informative. I hope you've learned a little something from it. Again, I hope it's been beneficial to you. And there are some attachments here on this webinar, so please look. You're going to see that I've attached a Zoeller startup sheet. I have another sheet that explains all of the boxes of the startup report in detail. I might even give you a little troubleshooting on some of them. And then the last thing that I attached was a basin or tank capacity chart. This is something that you can carry with you. And when you're out in the field and you need to figure out how many gallons a particular pit or basin might hold, you can use this chart and figure that out and figure out exactly how many gallons per inch the tank or basin you're using has. So when you do that functional drawdown test, you'll know exactly how many gallons per minute you got rid of. After we've ended this webinar, if you have more questions, please send your questions to webinars@zoeller.com. We will answer your questions. We will get them addressed. We will get back to you. So again, thank you for your time today. I hope you've learned a little something, and feel free to send in those questions to webinars@zoeller.com or call our product support department anytime. Thank you.